UGC NET Unit 2 Computer System Architecture December 2018 questions with explanation part 2. Question. Consider the following x86 assembly language instruction. MOV AL 153 NEG AL. The content of the destination register AL in 8-bit binary notation. The status of carry flag and sign flag after the execution of the above instruction are. Explanation. The NEG instruction negate the values by finding 2's complement of the single operand. So the first instruction is MOV AL 156. This means move 153 in register AL. Then negate the AL. So first we represent 153 in binary, that is 100110001, and negate this 153. It gives 011001110, and find the 2's complement of this. We get 011001111. When a 16-bit instruction, the first bit, the 0th position is carry flag, it's set, and second position is parity flag, it's set. Like this diagram will show, 7th bit is state sign flag and 0th position is carry flag. Here the carry flag is set 1 and sign flag is set 0. So the answer is AL value is 0110 0111 and CF carry flag value is 1 and SF flag value is 0 is a correct answer. But on online so many wrong answers are available. So we check this program in 8086 emulator. In 8086 emulator, we type this program, move AL 153 and negate AL. When we compile this, we get carry flag is 1 and sign flag is 0. So carry flag 1 and sign flag 0 is a correct answer. AL equal 0110 0111, CF equal to 1 and SF equal to 0. Next question. The decimal floating point number -40.1 represented using IEEE 754 32-bit representation and written in hexadecimal form is. The options are given. First we convert -40.1 into IEEE 754 32-bit representation, and then we find the hexadecimal form. So first we know the 40.1 binary values. So 40.1 binary value is 10100.0001110. Then normalize the number, that means the point is preceding before. So 1.0100001110 into 2 power 5. The 2 power 5 means we locate the point before 5 point. The IEEE representation is plus or minus m into 10 power e minus 127. M means Mandisa. The bias exponent is e plus 127. So here the 2 power 5 value is a bias exponent. So 5 plus 127 equal 132. In 132 in binary is 140100. The IEEE representation is sign value and exponent and mandisa. Here sign value is negative and exponent is 132 and mandisa is 0160110. Here the sign value is negative, so we put 1 and exponent value is 132. So we write 132 in binary 140100 and mandisa value write as it is. Now we convert into 32-bit representation. Then we want hexadecimal form, so we group 4-4-bit in 32-bit representation. Then we get C22046. So C22046 is a correct answer. Next question. Find the boolean expression for the logic circuit shown below. Here 1 NAND gate, 2 NOR gate and 3 NOR gate. First we take A, B as an input in NAND gate. It gives A dot B whole bar. Then we calculate B A bar in OR gate, XOR gate. It will give A bar plus B the whole bar. We took input as A bar plus B bar and A dot B bar and NAND. Then the the output is A bar plus B bar plus A dot B bar the whole bar. We simplify this, we get AB. So the answer is AB.